All right, so I'm gonna backtrack just a bit because this part I didn't get a video made for. And so I got it made for product rule, but not for power rule. So power rule, folks, we are raising something to a power and we're multiplying the exponents, but the coefficients still get raised to a power because the coefficients do not behave the way exponents do. So number 8, which we've already done in class, -8 to the second power is 64. And then C, 5 times 2 is C to the 10th power. All right, and now we're gonna go down and look at 14 and 16 that involve using power rule, which again is on that first sheet of notes, using power rule. And then after we've used power rule, we're going to use product rule. So we have to use both in the same problems. So scroll this way and down. All right, so just so I have lots of space, I'm going to rewrite number 14 down here. And sometimes you don't have to use power rule on both. For instance, for this problem, we're going to have to use power rule on the first monomial, the first set of parentheses, but not the second, because the second doesn't have any exponents hanging out on the outside, but the first one does. So 3 to the second power is 9, and then multiply the exponents. So 6 times 2 makes that 9 to the 12th. 9y to the 12th, sorry. Now the second part doesn't need to change, but now what I'm doing is multiplying these two things, and we know multiplication is product rule, where if there are coefficients, they actually multiply, but exponents get added. So there's only a 9, so it's still going to be 9. It's like 9 times 1 is still 9. And then alphabetically with my variables, so I'm going to put my x first, x to the 5th, then 12 plus the 2 makes y to the 14th, and then the z. So that one didn't involve too much product rule because there was only one variable to put together. 16, we're going to have a little more work to do. So 16, since it's lined up right here, I won't rewrite it to start with. So 14 to the second power first. Someone help me out. What's 14 to the second? Yep, I got 196. And then multiply each exponent inside by the exponent on the outside. So a to the 4 times 2 makes a to the 8th. Now, if it would help you to make like a couple notes where you wrote 4 times 2 in the exponent to see where it came from, but I find most people just kind of do that mentally. But you may want like a problem written down where you write that so that you know, like when you look back at it, where did that come from? So that's the first one. Now I've gotten rid of that exponent on the outside. So then the second half, this guy over here, this monomial, I need to get rid of his exponent that's on the outside. He doesn't have a coefficient, but 6 times 7 is 42. So A's new exponent is 42. B's new exponent, 3 times 7 is 21. And then there was no plus or minus in between these two things. So it does indicate multiplication after, which is why we use product rule after. So then the 196 is still 196 because there was no other coefficient, or it's understood to be a 1. 1 times anything is itself. And then add my exponents that are on like bases. Use that product rule. So 8 plus 42 is 50. B, 12 plus 21 makes 33 as my exponent on my B. And then you have 9 problems at the bottom to finish. Now, if there's a particular one of those that, or a couple that people have questions about, I am glad to answer those questions. So if you're finishing the notes, those would be the ones you would be doing independently. You can snap a picture of that to let me know, or in iExcel, that lesson is not Y2. That lesson is Y5 actually. So that lesson is Y5 on powers. So if you prefer, you can do that iExcel lesson instead, or if you just want to get some more practice before the quiz. The next quiz will come up pretty quickly because we do while unit 4 was all 1 unit in Odysseyware, it's really our polynomials and factoring unit. And so, which in some ways it's really nicer to have more frequent quizzes because then there's not so much different information on the quiz. So I think you'll find that actually to your advantage. So, so we only have a couple days of material, and it may be next Monday or Tuesday that you have a quiz again. So have another opportunity to shine. So these ones at the bottom, or you can do the iExcel lesson. If you have trouble reading any of these, please let me know. I know that the print in your packet is really small. Or if you want me to send you the PDF copy that you can enlarge as much as you want to see things, although sometimes it gets kind of fuzzy when you enlarge. Let's see. The bottom row is the only row that has numbers involved. I'm going to go.
I do have a question for you when you have a moment, Miss Carolyn.
Yes.
It's on iExcel.
Okay. Hold on a second.
That's fine.
When I'm screen sharing, sometimes I lose the chat. No worries, Brandy. I'm recording. All right, so now we're going to talk about quotient rule. Who remembers what is a quotient? What does quotient have to do with? Awesome, you can show me in just a couple minutes. Perfect. I was going to say, I think 27 was the one you showed me first. So this is our last page. So if we get done when you have some time and you just want to, you can try some of those iExcel lessons too, just for some extra practice with this. But I think once you get it, it really does flow pretty well. So quotient, product rule had to do with when we were multiplying, because the answer to multiplication is the product. Quotient is the answer to what? Yeah, division. Quotient is the answer to division. So division is typically going to be written as fractions. So when you see a fraction, you're going to think, ah, they just mean divide, right? So when we were multiplying with product rule, we added the exponents. So now that we're going to be dividing, we're going to subtract the exponents. And again, the coefficients do not behave like the exponents. They're still going to divide, or if they don't divide, we're going to reduce it and leave it in a fraction. So I'm going to give you, there's going to be a few different, I've taken out some other stuff that had been on the page. I'm actually going to work down the right-hand column. And hopefully this is in there. Ah, okay. All right. Let's see. Kiki's brave. She's going for it. So what do you think? This first one, well, oh, you said you probably did the very first one, not that first one over there. So what do you think? I have a squared over a squared b squared over a cubed b. I should probably also warn you guys, no negative exponents. If we had a negative exponent, then we got to do work to change it. So we don't really want to have to go through that step. So just think, I'm going to put it where there's the most. I'm going to subtract, but like if the bottom has more, then that's where the answer is going to be. Because I don't want to get -1, because then I have to like rewrite that, and that's just a pain. So when you look at the A's, the most A's are in the bottom by 1. The most B's are in the top by 1. So that's my answer, B over A. So why does this work? Well, this A squared is A times A, B times B, and then the bottom would be A times A times A, and just one B.
Yeah, I did not get that right.
And then what would happen is these would cancel out and those would cancel out. And what do we have left? We have a B in the top and an A in the bottom. You do not need to write all that out. That's just how I'm showing you why it works. Here's how I think about this. I think about it kind of like the North and the South. And there's a war going on. The X's are fighting each other, the Y's are fighting for control, the Z's are fighting for control. Some of them are going to get control of the top because they got more up there in the north. Some are going to get control of the bottom. Some are just going to kill each other off, and there's not going to be any of those variables left. That's what happens when they're the same, right? So I don't mean to talk about killing, but that's kind of how I think about it, sort of. So when I look at this far one to the right, the Z to the 6, Y, or X to the 6. So if we can do this one, we can do the other ones in that row because they are actually shorter. So when I look at the X's, so I'm just looking at one variable at a time, not trying to look at the whole thing. And I ask myself, where is there the higher power, top or bottom? Well, for the X's, the higher power is in the top. How many more? 6 take away 4, that's going to be X to the 2nd. Then I look at the Y's. Where's there the higher power of Y? Also in the top. Now that Y in the bottom, he's sneaky. That's not 3 minus 0, that's 3 minus 1, remember? So this is going to be Y to the 2nd. So 1 for 1, they killed each other off, but there's still 2 more Y's in the top. The Z's, I've got 1 Z in the top and 2 in the bottom. So the Z wins the bottom. And that's what my answer looks like. That's my final answer. I'm done. So it's just like a little battle between each set of variables. Whichever top or bottom wins, that's where the answer lives. If everything cancels out of the bottom, if everything was higher power on the top, then it wouldn't need to be a fraction anymore. If everything was a higher power in the bottom, we would have to put a 1 on the top so that it still looks like a fraction. So for instance, if I had x to the 5th over x to the 7th, then I'm going to have to say, I can't just leave it like that. I have to put a 1 up here. But if it had been the bigger exponent on the top, I could just say second power. And remember, we said negative exponents mean reciprocal. So if I had done 5 minus 7 and I got x to the negative second, and then I used what I told you guys about at the beginning, that negative exponents go to the denominator, I get the same answer, but to me that just feels like extra. Like that's just extra work. If I can't leave it with the negative exponent, I don't even want to go there if I don't have to. I'm just going to go ahead and see like, okay, who has the most to start with. So when we get to the next row with the 8ab squared c cubed over 16a squared b squared c cubed, 3 variables again, and then this time we have also coefficients. So the 8 and the 16, don't subtract them. They still behave like a regular fraction. So 8 over 16 would be the same thing as 1/2. Or you could just put a 2 in the bottom. You could just put a 2 in the bottom if there's something else left on top, which actually there's not going to be. So we do want the 1. Then I'm going to look at my a's. Higher power of a's in the bottom by 1, right? Because it was a 1a on top. That's the first power, second power. The b's, it was b to the second, top and bottom. Those guys, they just wiped each other out. They're out of existence. The c's, same thing. So it's just 1 over 2a. And if I just had 2a in the bottom, I would have to go back and put a 1 in the top so that it's understood to be a fraction. So when they're canceling out, they're not really giving us 0. They're giving us 1s, but I don't really need to write 1 times 1 times 1 because it still equals 1. So if something canceling out is not making a 0 in this case, it's not like a 0 pair, it's a 1, but 1 times anything is just itself. So that's why we don't typically write 1s when they cancel. There's something else there, so we don't have to write the 1, but they're not part of the answer anymore. So we get some with some negative signs tossed in. So my next one here, I'm looking at the 16 divided by -4. So that's -4. Then I'm looking at my x's. Higher power of x is on top by 1. I could put an exponent of 1, or if I just write x, it means the exponent is 1. And then y's, the higher power of y is on the bottom. There's 2y, second power on the bottom, only first power on the top. So the y in my answer is going to be here. And that's it. It's done. So my next one, -24 divided by 6. Got another -4. My x's, higher power. So that's what you want to ask yourself. Where's the higher power? Higher power of x, denominator. So I know x is going to be in the bottom. Then 4 take away 2 is 2. Higher power of y, numerator, top. So y is going to live in the top. 4 take away 2 again is 2. If there are 2 negatives, remember this is division. So remind yourself of the rules for division. When the signs are the same and you're dividing, the answer is going to be positive. Now we really don't want to say 0.5 though. All right. I know that 7 divided by 14 is 0.5, but we want to stick with a fraction form. So I'm gonna need to move this a little bit. My iPad on my picture is in the way. So -7 over -14, just thinking about that like a fraction, would be 1/2. And then when I look at the x's, more on the top. 4 minus 2 would be 2. I look at the y's, more on the bottom. 4 minus 3 would just be first power. Now, I could write that just like that. 1x squared over 2y to the first. We've talked a little before about how mathematicians like to be efficient, right? So if I were trying to do this the most efficiently with the least characters, this would just be x squared over 2y. Those things both mean the same thing. So since there is something else in the numerator, in the top, I wouldn't have to write the 1. And since we understand that the exponent is a 1, if we don't write it, I don't have to write the exponent. It's not wrong if you do, but just know, like, those two things do mean the same thing. So this bottom one, it doesn't actually, like 12 doesn't go into 18, but we still reduce the fraction. And we want to reduce it as much as we can. So I'm kind of thinking about 12 over 18. Some of you are immediately going to think like, oh yeah, I know 6 goes into both of those. Some of you, your minds don't work that way. Okay, you can do it in one step. You could reduce it in more than one step, but you need to reduce it as low as it goes. So maybe I just think, well, they're both even. So divide them both by 2, then that would be 6 over 9. And then maybe I go, oh, 3 still goes into both of those. And I divide them both by 3 to get 2 over 3. Or you just divide by 6 to start with, and this is 2 over 3, because 12 divided by 6 is 2, 18 divided by 6 is 3. So this may be something you need scrap paper for, or it may be something you just do very naturally in your head. And then I go back to deep breath, don't get freaked out by the fraction, and go back to, oh, where are the most A's? On the bottom by 1, remember, because this guy counts as 1. The guy on top counts as a 1. And then where are the most B's? On top by 1. And then the C's cancel each other out. There is no C in my answer. It's just 2b over 3a. Also notice, like the a in the numerator, he doesn't get to piggyback on the b's too. He does not own that exponent. He has his own exponent that's a 1. So 2b over 3a would be our final answer. And if you're doing IXL, that is probably Y3. And then Y4 is a mix of those, which maybe, to be fair, I should make that like not part of the assignment since there's only 3 pages. So you have similar problems in the other column. And if you're working on those and you want to ask to be sure that you have the right thing, this would be a great time to do so. I'm gonna switch over here to, of course I closed IXL last time I was in there. Of course I did. So I'm gonna take a look at that IXL again. If you are all caught up and you have some extra time and you want to just do some more to make sure you've got it, you are welcome to do those. Know that if you are in class today and you send me pictures of that you finished your notes, If you choose to do the IXL, you don't have to then get it up to 80. You could just do a few. Let's see. So the divide in Y3, we looked at some extra of Y2 when Cassie was sharing. If something cancels out completely, it's a 1, because 3 divided by 3 is 1. Anything divided by itself is 1. So while normally, as I talked about, we usually just kind of mark them out, it's not like canceling out in 0 pairs, it's a 1. Nope, that's it. So I'm just going to do a few of the examples on IXL in case people choose that option. That's all. Thanks, Mackenzie. So 10 divided by 10 is 1. So I don't have to put the 1, but I could. And then we'd have y and then to the 7th. So notice they are going to give us a way to do a fraction so that if there's stuff in the top and the bottom. Yes. So you can either take pictures that you finish those pages in the notes, or show me on camera today that you finished those pages in the notes, or you can do the IXL. So we have quite a bit of time, so it probably either is fine, but it's okay if occasionally we are done a little early so that, because if people get behind, they need the time to catch up. Awesome. So this one, the 3's would cancel out. That would just be a 1, but there's more J's on the bottom. So I'm going to need to click my fraction button, and then I just have a 1 on the top, and then J to the 2nd on the bottom. Yep, I'll see you tomorrow then. Looks like I'm getting a lot of ones on the top. Let's see if I scooch on. Let's see, I know this is going to get harder.
I'm doing a little extra work on IXL, but I'm almost complete. So I'm going to pop off here.
All right. So when you're doing this division, if you're doing Y3 on IXL, which if she's doing IXL, she might have wanted to stay for this, but okay. So when you're doing this, and I'm not sharing what I intend to be sharing. There we go. So a problem like this one, whew, there's a couple ways to think about this. I think about like those negative B's in the top, they're really like spies from the other side. They're really on the south side and they're just living up north for now. They're not happy there. They're not happy in the north. They're going to come to the bottom where they can become positive. Now they're both in the bottom, so they would get added together down there. So this would be 7 divided by 7 is 1. And then there would be 18 B's on the bottom. So there's a couple ways to think about why that happens. One, those B's in the top, not happy in the top, they got a negative exponent. They come to the bottom. They're joining forces with the south. So then 9 plus 9 makes the 18. You can also think, which one's bigger, 9 or negative 9? Hello, 9, right? 9's bigger than negative 9. And if I did 9 subtract negative 9, what happens there is we add the opposite and it becomes 9 plus 9, still makes 18. We do need the fraction. So I click fraction, 1 on the top because nothing's left up there. Just 7 divided by 7 is 1. B, not fraction again, B to the 18th. So here, this one's a little interesting. So keep in mind that this j on the bottom, so this is 9j to the 0. This j on the bottom, he has a 1. The only whole number, only coefficient's in the top. So it's still going to be in the top. And then which one's bigger, 0 or 1? Well, 1, of course. And 1 minus 0 is just still 1. So this is just going to be a j. And I'm pretty sure if you put the 1, they still take that. You wouldn't have to. You could just put j, but they also accept it with the first power. So when we get things with two negatives, I would just, usually what most of my students helps them is just to put the negatives where they would make positives and then do the problem. So I know that 9 over 3 is going to give me 3. That's the easy part. There's going to be a 3 on the top. And then that c to the 9, he's not happy there. Those c's are going to come down to the bottom to become positive 9. But the c's in the bottom, they're not happy there. They're going to come to the top to become positive 8. Then where's there the most? Now that they're positive. Oh, in the bottom by 1. So this would just be 3 over c. Again, alternate way to think of it is who's bigger, which one's greater, -8 or -9? -8 is bigger, so I know c is going to be in the bottom. And then I'm doing -8 subtract -9, and I get plus plus, which makes that +1, which is why this exponent is a 1, but it's in the bottom. Most of my students find it's easiest just to rewrite it. If they're negative, switch spots and then do the problem. Now, this one, they both switched because they were both negative. But if only one's negative, then that's the only one that needs to switch places. All right, so I am going to make a slight change on what's on the daily board to say, let's see, this is 3, to say y2, 3, and 5, and not y4. I mean, you could still do it, but because there were 3 pages that I asked you to finish, so finish those 3 pages or do 3 IXL lessons. Y4 is just going to mix it up. It's going to have some multiplication and some division. So if you want to practice all of them, you certainly can. So if you're doing the IXL route, Y2, 3, and 5. If you're doing the paper route from your notes, doing the paper route like you're delivering newspapers, haha. Then you're going to do pages 27, 28, and 29. So I'm going to stop sharing and stop my video. And then if any of you who are on are ready to show me if you have your stuff done, then you don't have to worry about sending it.